Shared outputs satisfy x squared equals x plus 2.
Watch the scene first. Our snow leopard Frost needs to track exactly where a straight snow path crosses a curved basin. To figure this out, we need to solve a simple system consisting of a linear equation and a quadratic equation in two variables. The quantities and structure can be seen right here in the physical landscape before we ever write down an equation. The exact spots where Frost's straight path overlaps the curved track are the mathematical solutions to the entire system. Moving into the straight paths, we can map these two paths. The straight line is marked as y equals x plus 2, and the curved parabola track is y equals x squared. To find where they cross, we look for where they share the same output. We set them equal to each other. X squared equals x plus 2. We rewrite this into standard quadratic form by subtracting x and 2 from both sides to get x squared minus x minus 2 equals 0. Factoring that gives us the quantity x minus 2 times the quantity x plus 1 equals 0. This tells us the x values are 2 and negative 1, but a location needs two coordinates. We plug these x values back into either equation to find their matching y values, giving us heights of 4 and 1. The solutions are 2, 4 and negative 1, 1. Looking at the wide curved basin, we can plot those two coordinates directly onto the snowfield grid right at the physical crossing points. An intersection point lies on both graphs.
Both curves meet at negative 1, 1 and 2, 4.
That means both equations have the exact same output at that specific location. The intersections are the system's solutions, because both equations are true there. Moving up to the algebra ledge, Frost spots a different scenario. Here, a straight path barely grazes the curved parabola track, touching it at exactly one point. A touching point like this still lies on both graphs. Since there is only one such point, the two paths share only one location. It would mean the system has exactly one solution. Let's pause and verify our earlier work at the shared crossings. We can test if the point 2, 4 actually works for both equations. First, check the quadratic. When we plug in 2 for x, we get 4 equals 2 squared, so it fits the y equals x squared path. Next, check the line. Plugging in the same values, 4 equals 2 plus 2. It fits the y equals x plus 2 path as well. Because it satisfies both equations, it is a solution pair. Yes, 2, 4 is a solution to the system. Pulling back, the straight paths, curved basin, algebra ledge, and shared crossings form a single continuous landscape, with every calculation permanently marked. Every leap and turn matches the numbers and symbols found along the trail. Frost settles onto a ledge as Pip, a young red fox kit, bounds into the lower valley, their physical tracking complete. The environment physically shows the relationship between the paths, and the mathematical notation simply records it.
2, 4 satisfies both rules.